Let us start the second lecture on trigonometric equations. And before using the formulae that we studied in the first lecture, let us study about two general questions: sin x equal to root 3 by 2 and tan x equal to minus 1 by root 3. What I am saying is, for a moment I want you to forget about the first lecture that we derived the general solutions and principal solutions there, and focus on this only, right? So sine of x equal to root 3 by 2, tan of x equal to minus 1 by root 3, these are two separate questions, and I am looking for only the principal solutions. What are principal solutions? I am looking for values of x that lie between 2 pi and 0. So x should be greater than or equal to 0 and less than 2 pi. Now think about this question here. Sine of x equal to root 3 by 2. So if I can show you in the diagram, so this is a positive value, right? So, and I also know what is this angle. This is pi by 3, right? So this will be in first quadrant, and I'll have the same value, or let us say another position of this point where the sign will give same value in second quadrant, because in third and fourth quadrant it will give negative values. So that is not acceptable to me. I just want values between 0 to 2 pi. So another value will be here. So if one of the rays is this, which is pi by 3 here, right? So another ray will be this one, which is pi minus pi by 3. So my principal solutions are pi by 3, which is pretty obvious. This is something that we need to memorize, right? The values between 0 to 90 at least you should know. Sine 0, sine pi by 6, sine pi by 4, sine pi by 3, and sine pi by 2. These values should be memorized, and for all other trigonometric ratios also. So pi by 3 is one of the values. Another value will be this one, pi minus pi by 3, right? So between 0 and 2 pi, these are the only two solutions. We will have infinite number of solutions. If I come back to it once more, 2 pi plus pi by 3 will be another solution, right? But that will not be principal solution. For now, for this particular question, I am looking only for solutions between 0 to 2 pi. So these are the only two solutions, that is pi by 3 and 2 pi by 3. These are my principal solutions. What about tan of x equal to minus 1 by root 3? Now we know tan of pi by 6 gives me 1 upon root 3. Now this is negative 1 by root 3. So it will be tan of minus pi by 6. That will give me minus 1 by root 3. Right? So, okay. Where will it be minus? For example, this is pi by 6. So here it will be minus pi by 6. Right? At this position. So at this point P, I'll have tan of x as minus 1 by root 3. So what will be other position of tan where I can have minus 1 by root 3? Here, right opposite, right? Why? Because if you see, there can be many ways to understand it. Number one, if I wanted 1 by root 3, I would have got it here, and then another position would have been this one. I would have got it here also, 1 by root 3. But now I need minus 1 by root 3. So it can be here at this position and here, because sine and cos have different signs in this quadrant and this quadrant. Because in this quadrant, sine is negative, cos is positive, and in this quadrant, cos is negative and sine is positive. So tan will be negative in these two quadrants. So these are two positions that I am looking for. Now this position is nothing but pi minus pi by 6. So this will give me one of the solutions, and this position is minus pi by 6. So it can also be 2 pi minus pi by 6, right? Because this is 2 pi. So I want something lesser than 2 pi. So 2 pi minus pi by 6. Pi minus pi by 6 will give me 5 pi by 6. And 2 pi minus pi by 6 is 11 pi by 6. So these are my principal solutions. or if you are not comfortable with this circle, you know that I have taken tan of x as minus 1 by root 3. For a moment, you think about only 1 by root 3. So you are thinking about pi by 6, right? Now, you have got pi by 6, right? So pi by 6 will give me 1 by root 3. So what will be tan pi minus pi by 6? It will give me minus tan pi by 6, right? Which I require. So this is one of the angles that I am looking for, which is 5 pi by 6. Another angle can be, now minus pi by 6 is my angle. So if I add 2 pi in it, right, it will be lesser than 2 pi. So this will be another solution. Now I don't know how comfortable you are with these ideas. 11 pi by 6. So these are two principal solutions, right? And I don't want you to memorize these things, because you can very well use this circle and find these values, or you just know that you need values between 0 and 2 pi. So you can anyways add any number of 2 pi's in an angle. So you have got minus pi by 6, so you can add 2 pi, right, without changing the ray, because if you rotate some ray by 2 pi, it will come back to it. So you can add 2 pi in it, right? And about the other position, I have explained it to you. Now let us come back to the general solutions. I know if sine x is equal to 0, that means x is multiple of pi, where n belongs to integers, right? If cos x is equal to 0, then that means x is odd multiple of pi by 2, odd multiple of pi by 2, where n is an integer. This is something that we have studied already. Now if you are given an equation sine x equals sine alpha, I am doing this lecture especially for NCERT students, those who are studying from NCERT book, because this is the solution, this is the way they have explained it. So it is for you, right? Otherwise I have already told you about the equation, that was enough, but let me do it for you. So sine x equal to sine alpha means I can write sine x minus sine alpha equals 0. Now I know sine c minus sine d formula, so I'll apply it here. What is sine c minus sine d? 2 cos c plus d by 2 sine c minus d by 2. So I am applying it here. 2 cos x plus alpha by 2 sine x minus alpha by 2, and it is equal to 0. Now it is in product form. While solving trigonometric equations, my endeavor should be to bring it in product form, that a into b is equal to 0, so that I can say that either a equal to 0 or b equal to 0. So this will give me my solution, right? This equation will give me my solution, this equation will give me my solution, or means union of these solutions, right? So I'll choose, for example, a equal to 0 gives me, let us say, 3 solutions, and b equal to 0 gives me 3 solutions. Then I'll take union of these. Okay, if there is some common solution, then I will not count it twice. So if, for example, if this gives me 3 solutions, this gives me 3 solutions, I will not say there are 6 solutions. I will take out common solution. For example, if one of the solutions is common, I'll say only 5 solutions are there for this equation. I hope you understand it, that my endeavor should be to bring it into some product, that a into b equal to 0, then a equal to 0 or b equal to 0 give me my solution, or gives me the sense of union. Okay, now we are in a similar situation here, because product of this and this is equal to 0, so which gives me either cos x plus alpha by 2 is equal to 0, or sine x minus alpha by 2 is equal to 0. Now I know cos x equal to 0 implies that x is odd multiple of pi by 2. So here x plus alpha by 2 should be odd multiple of pi by 2, right? I can cancel this 2 here, and x is equal to odd multiple of pi minus alpha. Now here, this is other part, so sine of some angle is equal to 0, that means x minus alpha by 2 is equal to n pi, right? So x minus alpha is equal to 2n pi, and x is equal to 2n pi plus alpha. So I've got these solutions that x will be equal to odd multiple of pi minus alpha, or x will be equal to even multiple of pi plus alpha, and I can collectively write them as n pi plus minus 1 raised to power n alpha, because minus 1 raised to power n will be 1 when n is even and will be minus 1 when it is odd. So whenever you want whenever you want to incorporate both the signs plus and minus, and even value of n has to give you plus and odd value of n will have to give you minus, so you can incorporate both the signs by using this. Now if you see, if n is even, this will give me even multiple of pi, even multiple of pi, this will give me plus alpha, right? So I have incorporated both these statements in this statement here, which is my solution where n belongs to integers. So this is the general solution for sine x equal to sine of alpha. Now similarly we can work out for cos x equal to cos alpha, then cos c minus cos d formula. What was cos of c minus cos of d? It started with a negative sign, minus 2 sine c plus d by 2 sine c minus d by 2. This was the cos c minus cos d, so I am going to apply it here. So minus 2 sine x plus alpha by 2 sine x minus alpha by 2 equals 0. Now it is in product form, so either this will be equal to 0 or this will be equal to 0. So to solve this equation, what I can do is, so either sine of x plus alpha upon 2 will be equal to 0, or sine of x minus alpha upon 2 will be equal to 0. So if this is equal to 0, then x plus alpha by 2 will be equal to n pi, right? So that means x will be equal to 2n pi minus alpha, or this to be equal to 0, x minus alpha by 2 will be equal to n pi, so x will be equal to 2n pi plus alpha, right? Now I can write these collectively, this one and this one, because this is alpha before 2n pi and this is alpha after 2n pi, so I can write it as x equal to 2n pi plus minus alpha. Now this is my solution for cos x equal to cos alpha. Similarly, you can talk about tan x equal to tan alpha, tan x equal to tan alpha. So I can write it as tan x minus tan alpha equals 0. If I bring them into sine and cos, this will be sine x by sine, this will be sine x by cos x, this will be sine alpha by cos alpha equals 0. So I can write it as sine x into cos alpha minus cos x into sine alpha divided by cos x into cos alpha, and it will be equal to 0. So whenever we are talking about tan here, right, we are talking about tan, we mean that x will not be equal to odd multiple of pi by 2. So in all these equations, or when I am working with trigonometric functions, I mean wherever they are defined, right? So if x is odd multiple of pi by 2, tan is not defined, so there is no question of solving that equation if x is equal to odd multiple of pi by 2. So it is assumed when I started solving this equation that the angle involved is not odd multiple of pi by 2, right? Okay. So for this to be equal to 0, this numerator has to be equal to 0, right? Because denominator cannot be 0. So the, or you understand that if this is 0, obviously the numerator is 0, right? And what is numerator? Sin x cos alpha minus cos x sin alpha, right? So this is nothing but sin x minus alpha. So this numerator has to be 0 for this equation to be 0, right? We know sin a minus b is what? Sin a cos b minus cos a sin b. This is the identity that I applied here to write this. Now sine of an angle to be 0 I'll have that angle equal to n pi, right? So that means x will be equal to n pi plus alpha, and this is my general solution for tan x equal to tan alpha. I hope these solutions are clear to you, because we have already discussed about these solutions using the unit circle, and that was also pretty easy, right? Because for sine it can be here or it can be here. So if this is alpha, this will be alpha here. This is odd multiple of pi, this is even multiple of pi. So it was even multiple of pi plus alpha or odd multiple of pi minus alpha. For cos it will be here, right? This will be minus alpha. So even multiple of pi plus alpha or even multiple of pi minus alpha. For tan it will be here. So odd multiple of pi plus alpha or even multiple of pi plus alpha. So this, if you can keep this in your mind, all the equations will be there in your mind, right? Now I think let us move to the questions. So this question I think we have already done, right? Let us look at what we have got next. This is also we have already spoken about. Now let us look at this.